All right, this is a slide I actually have needed to update, and I think I did update it in another class where I used the same slide, and then I forgot to do it for this one, but it's been a long day, so I'm just going to roll this video and talk about what the nature of the update should be, because it says here in the slide that the modern definition for the Kelvin unit is based on the triple point of water, and it turns out that was true prior to sometime around spring of 2019. You could Google exactly what, I thought it was March, but I could be wrong, when the new definition of the Kelvin unit took effect. And the new definition of the Kelvin unit is actually based on a defined value of the Boltzmann constant. It is no longer based on the triple point of water, but prior to that, it was for a long time. And that was good, and is what this question is related to, because it says that, it's asking us why might this be a better definition than the freezing or boiling points. I skipped over the part where it says, in other words, the triple point of water is defined to be at 273.16 Kelvin, which is 0.01 degrees Celsius. So again, that is the definition that was in force prior to sometime in 2019 when the switch happened. Why that worked out pretty well and why that was better than previous definitions of temperature scales, which tended to be more focused on those freezing or boiling points, is because, as we can see in this kind of diagram, this is a pressure versus temperature phase diagram that you can see similar ones for different substances, but this one has got a shape that roughly corresponds to water. And it kind of shows that critical point when we looked at that earlier diagram where we had isotherms. That is actually that same critical point there, above which kind of the difference between vapor and liquid ceases to be meaningful. But again, this could be used for water. But the issue is that, as you can see, like, this nearly vertical line is not quite vertical. And the reason why is, as you change pressure, the freezing point shifts. And water is maybe slightly unique in the way this is kind of slanted leftwards. But that issue makes the freezing and or boiling points kind of a less good standard for the definition, because, like, let's say you went to some other planet and you said, oh, I want to make a thermometer, well, let's just boil some water. It's not going to work, because the air pressure is probably, provided there's even air on the planet that you can breathe, right? But whatever that is there is probably going to be at a different pressure, so that's why that wouldn't be so good. So in that sense, having a definition based on the triple point, all you'd have to do is find some water and do the appropriate experiment. So it's a little more universal. But the modern definition, in that sense, represents progress towards an even more universal basis for all of the units, all of the base units in particular. And it's pretty complicated. I think they spent a long time. I remember, actually, I think first hearing about some of the proposed changes back in like 2010, and at that point I think they thought they were going to have it knocked out by 2012, and then we had to wait until 2019 for things to actually happen. That's my recollection, so I could be wrong about some of that, but definitely we've been waiting for a while. Scientists have been thinking for a long time about what would be appropriate redefinitions that have even more kind of universality to them for the base units, and that included temperature, but also included, more importantly perhaps, the definition of the kilogram, which previous to that was based on an artifact and now isn't. So that was actually a huge benefit. One of the issues that came up with the redefinitions, though, is when you redefine something, you need to make sure that you have the experimental technology to be able to create calibrated instruments based on the new definition. So that's where the story gets a lot more complicated. I think it's probably time for me to stop talking about it, though, and I'll say, if you want to look that up, it can be fascinating reading, but there's a lot involved to it. There were a lot of debates about how to establish things and what experiments could be used for things. But let's see what this thing says. It points out the freezing and boiling points depend on pressure, but the triple point is more universal, and that it is defined independent of a condition of the environment. And of course, as I've said, defining the Kelvin based on a purely defined number is maybe even more universal than that, because now you don't even need a particular substance to define it. Maybe there's still something there when it comes to how you would calibrate an actual thermometer based on the new definition.